Today we'll be talking about only few things, what we call them abstract classes and interface. So now, see, basically, whenever you want to define, whenever a class defines some abstract concept, then in that situations you have to use abstract classes. For example, sometimes you have a take example of a food in real life. Now I can't create an instance of a food. So what we are talking about is that whenever we have to represent an abstract concept, abstract class feature has to be used. But abstract class does not require any instance of it. And you have seen the example of a food. Food we don't have, you have not seen any real life example of a food. You have seen the instance of an apple, you have seen the instance of a banana, you have seen the instance of mango, but you have not seen the instance of a food. So basically what we are talking about is that food represents the abstract concept of the thing which we eat. In Java programming language, there are many classes are defined as an abstract classes. Take example of, for example, java.lang. We have a class called number. Number is defined as an abstract class. There is no, you can't have an instance of any number. You can have instance of an integer, you can have instance of a float, you can have instance of a cat, but you can't have a generic object of number type. So what we are talking about here is that whenever we have an abstract class, it is always defined as a superclass, or always defined as a parent class, and all other subclasses will inherit those characteristics and try to implement them. So we have a integer subclass which is an instance of an integer class. We have a float subclass which is instance of an integer, and all these subclasses implement certain characteristics of integer classes. So when we say abstract class, it means that it has got certain methods which are not implemented. That is why you can't create an instance of this type of class. Then only through subclasses those methods will have to be implemented. So now let's go to just see the more the precise definition. When we say abstract class, it is a class that can only be subclass, it cannot be instantiated. If a class contains all the implementation of its method, then you can create an object. But if any of the method defined into a class which does not require implementations details, we do not have any implementation support, then you cannot have an instance of it. So you cannot be instantiated, you can't create any object of it. But you can create any number of subclasses and implement all those methods which have been left unimplemented. So any class which is abstract class contains abstract method but no implementations. Now it is very similar to if you are coming from the C++ background, or if you are exposed to C++ programming language. In C++ programming you have a template class. So Java replaces template class through abstract classes, and also the basic purpose of the abstract class is to define the prototypes. Today we are not, the person who is managing the team, they define the prototypes, and other people who are involved in the team, they implement it. So the abstract class is used for implementing or defining the prototypes, and other people in the team are going to implement it. So let's see some real example now. What we have discussed now. Take example of, let's say I have to define a abstract class. Let's say this slide now we have to define a called abstract object. This is a class. And how do we define a class in Java? First you have to write a class. But if the class is abstract class type, first you have to write abstract. So I'm going to define a graphic object as an abstract class which has some parameters x and y, and then it has got certain method move to. We have not given a complete implementation of move to because the basic purpose of the lecture is to explain you certain concepts. So we have got one method called move to which has got certain implementation which we have not given them. When we say abstract class, it does not mean that none of the methods defined into the class is to be implemented, but at least there is one method at least one method which does not need to be implemented, which will be implemented by its subclass. In this program, in this subclass, you see that move to has got certain implementations. And then what we have another method that is to be noticed, what we have written abstract void draw. And so this method is called abstract method, which is to be implemented by all subclasses. So now you have abstract class. You must be having various methods which have been implemented. You must have some variables, like in the previous slide you have seen x and y are variables whose value must have been defined, but you must require at least one method which is abstract type, which will be implemented by its subclasses. That is why if any class, in summary what I want to say is that in any class, if a method is of abstract type, abstract method, then you cannot create any instance, because memory will be not be created due to some method which are not implemented there. Then what we have to do now? Now I am creating a instance. I am creating a subclass called circle. The circle extends graphic objects. So I can create a subclass. I can create any number of subclass. In this case, I have created the first subclass of graphic object type. So graphic object becomes a superclass or parent class, and then I am implementing its method, draw method. So now circle has its own draw method, rectangle has its own draw method, ellipse has its own draw method. This logic is different. So in the superclass I have given the prototype, I have given the structure, I have given the signature, and the other subclasses you implement them accordingly. So the draw will be defined for the circle different from the draw method defined into rectangle. Let's say again I have defined a class rectangle extends a graphic object void draw. So I have implemented another subclass which is containing the draw method, but this draw will be different from the circle. So this way I can go on and I can implement any number of subclasses of abstract class, and it must have at least one method which is defined into its superclass, but its logic differs from one to another. So now this is what we have. So abstract is a very important concept in Java programming language. Now the second important concept is called interface. Now if you remember, we have already talked about that Java does not support multiple inheritance. You can't write extents twice. You can write extents only once. It means that the syntax of Java does not support to write two extents. Two extents means you are supporting multiple inheritance. But Java has a different way of implementing the multiple interfaces. What it was found with C++, that if you have a multiple inheritance, then programs gets complicated and debugging also becomes very difficult job. So so multiple inheritance concept in Java is much more simplified than C++, which you will see here. Now in this case, but try to understand one important concept. When we say inheritance, does not matter is a single inheritance or multiple inheritance. What we are inheriting is, we are inheriting the data types, we are inheriting data structure, or what we call them array, and also we are inheriting the implementations methods, or method which have been implemented into the superclasses. This is what we mean. And also we can add to it. But when we say multiple inheritance in Java, we don't inherit any implementations of the methods. They have been simply defined but not implemented. So the multiple inheritance you can support in Java, but you are not inheriting the complete code listing, code design. You are simply listing the method names, data types, what type of data it returns, what type of data it takes, and arguments. It's a much more cleaner job, much more simplified job than C++. But let's come to the precise definition of what is an interface. An interface is a collection. Let's see the slides now. An interface is a collection of abstract concepts, methods, and constant values. So when we have an interface, we have a methods, but none of the methods have been implemented. But when we say abstract class, some of the methods are implemented, but at least one method is not implemented. But when we are talking about interface, it means none of the methods have been implemented. So a class can implement method from many other classes. Let's see so what other characteristics you have about interface. Interface add most of the functionality that is required for many applications which would normally resort to using multiple inheritance in languages such as C and C++. So the inheritance is basically replacement of of double extents in Java. You can do multiple inheritance but much more cleaner way. Now the another advantage of the inheritance or what we call the interfaces, that when you do inheritance, then there is certain relationship between the parent class and its subclasses. When you have a multiple inheritance in C++, again you must have some relationship between the two, and the relationship becomes much more complicated. So if you have a multiple levels of hierarchy and there is a multiple inheritance at each hierarchy, and since the relationship has to be established between the subclasses and its parent classes, then relationship will be much more complicated. So you have to conceptualize that relationship, then only you can have a multiple inheritance. Or say another way, to have a multiple inheritance in C++, relationship has to be established. All classes must be related together. But in Java, to have a multiple inheritance, you should not have this type of. This is what we have written, that the interfaces are useful for capturing similarities between unrelated classes without forcing a class relationship. There is no relationship between the class from which you are trying to inherit certain things, right? So this is what we are talking about inheritance. Now let's see the but again there is a hierarchy, but hierarchy is there, but a relationship is not type of relationship. What we are talking about is the interface hierarchy is independent of the class hierarchy. When we say class hierarchy, there is a relationship. Here we don't have such a relationship. The classes that implement the same interface may or may not be related through the class hierarchy. This is not true for multiple inheritance. The message is that you can have a multiple inheritance in Java without having any relationship between parent and subclasses, whereas in C++ you must have a relationship between the class wherefrom you are inheriting certain characteristic. So if the relationship is multiple inheritance type and number of hierarchy is also there, then it will be much more complicated. That is why the program gets much more difficult to debug if it's a multiple inheritance in C++, but is much more simplified than in Java. Now let's have with all these basic concepts, let's come to the how it is declared, because finally you have to understand how to define the interface in syntactical form. Now first thing is you just say the public. Now you know that we have already discussed that the Java defines various access mechanisms. In object-oriented program you have various access mechanisms. Not all the time you are authorized to access something from some other classes now. So there are various control mechanisms there. Public, if you define any class through public, means it is open to everybody. You can access a class defined in one package to another class defined into another package, right? So public is open for everybody. So and then we have a private and we have a protector. So they are much more restricted access control mechanism than the public. So how we define this signature? See, one thing is, this is a standard you have to understand. When we write something into a bracket, it means that it is optional. So whether you write or not, then it means it is always assumed to be public. But if you want to define them specifically, then you have to write it accordingly. But public, even if you don't define it, it will be assumed to be by the browser or by the operating system. So first we write interface, then write interface name, that is your name, whatever name you want to give, you can give them. Then extends list of super interfaces and the interface. So basically what we are talking about is that here is first you write the name, the interface, the way you define a class. When you define a class, you write the class. But for defining the interface, you write interface, and then you write the interface name, and then you try to write where from you are trying to, instead of extends, you have to write the implements. So implements the list of super interfaces. So now what exactly the meaning of this sentence, which I will give you through examples a little bit later on. Meaning of this statement is that you can write interface some interface name, and then you write implements the super interface 1, implement super interface 2, implement super interface 3, or super class interface 1, super class. So means that you can implement certain methods from many interface classes, but you can't extend from more than one classes. So you can have many implements as a part of your statement, but you can have only one extend statements in your statement. But where in Java, in C++, you can write extends many times, but here extend only once, but implements many times, because implement does not add any complexity in your program. So first you define the name of the class with interface and define the body of this one. For example, in this is written like, I am writing interface without any access specifier like public, private, or whatever it be, and then you write collection. This is the meaning. This is just the, you don't need to go about the meaning what we have here. Conceptually you have to understand. So we have defined the name of an interface. In fact, the definition goes like this, that any interface name must have A, B, L, E at the end, but it is not a compulsory, system has not given you any, you are not bound to declare it, because browser, the interpreter and a compiler just simply ignores it. So whether you don't add A, B, L, E at the end, or you use it, compiler takes it, does not give you any warning. So you simply write collection rather than collectionable, and then these are the bodies of my interface. What I have defined some variable, meaning is not important at this stage, and I have defined various method. One method is add, another method is delete, third is find, and fourth is current. Now just you notice one thing, that I have not given any implementation of these methods now. So when we have now you try to compare with your abstract class and with the interface class. Now with abstract you have seen that I have only one method which is not implemented, and some of the methods are implemented. Of course I didn't give you the body, but the meaning should be very clear. But when I define an interface, it means that none of the method which we have listed as a part of this body should be implemented. And then and you can define any number of variable, but its value should be defined. So I can define any number of interfaces, and a class can implement any number of interfaces. So it is much more simpler. If a class implements collection, what is carrying is simply it is carrying the value of maximum, but is not carrying the implementation code for add, delete, find, and this one. So it is much more simpler for a system to handle than inheriting all the characteristics, making up relationship between the super class and this one. So now what I am trying to do, now I am trying to implement. So I have defined a class called FIFOQ implements collection. This is what, if you remember, the signature goes like this, that we have a class FIFOQ implements collection, and then I am defining the method, I am giving the logic of add methods. So here is the logic of add method. Similarly, this class FIFOQ has to implement the delete also. So here one has to delete, one has to implement the delete method, one has to implement find method, and one has to implement the current count method. So you are simply inheriting the signature, the name of the method, and all its logic has to be defined by subclasses. In some way, your class, like in this is class FIFOQ, you can define, your class can implement any number of interfaces. By implementing interfaces means simply implementing the methods defined into that interface. With that, this is what we are talking about. So basically I have given you two major concepts, abstract classes and implements. Now abstract class is also very important. When you want to understand the architecture of Java programming language, you will see, for example, if you go to java.lang, if you go to java.awt, most of its super classes which is sitting on the top are basically containing large number of abstract classes, and the classes which are sitting somewhere at the lower level or at the middle layer, they are implementing those. It means that the base classes are always into abstract classes, which are, it means that base classes are abstract, base classes are of prototype type, and the other classes which are defined at lower levels are giving the full implementations of it. So this is very important to understand the complete architecture of your program, and whole Java library is defined into object-oriented style. Some classes on the top and other classes are inheriting certain characteristics from the top and implementing those things. Now with all those basic concepts, object, classes, polymorphism, inheritance, abstract classes and interface, now it's time to write few programs. Now the first program, the basic purpose of these programs will be to introduce you some other classes which we are not able to cover while explaining these concepts. But these classes are very useful, you have to understand them. Now my first program is introducing the math class. Now whenever I write a program, remember in Java, whenever you write a program, you have to import certain methods, right? Except only one library which is automatically imported with your program, what we call in java.lang, and java.lang contains the classes which are required by programmer quite often. They basically contains the classes related to the maths classes. They also contain the classes for defining multi-threading. They also contain the classes for handling the standard I/O, for example keyboard. Remember system.io, we have written system.out, system.in. All these classes basically, or system classes, are defined into java.lang, which you don't need to import. By importing means that including the classes with your program, but except java.lang, all other classes you have to import them. So on the top you have to write import java.awt and something like this. You can import particular class also rather than importing the entire package. Now just in this program, now what this program is, just in this slide now, here is a small program that uses some of the math class methods. So the purpose of this program is to introduce you math class and some of its methods now. So you don't need to try the basic. The habit should be in Java is to use the all defined classes, and to know all these classes you have to know its methods, you have to know its interfaces now. So let's say what I am defining then. I am defining public class my math. This is my class name. No import because java.lang automatically imported. Then you must have a main method, and a main method does not require does not return anything. It is a void type. It is open, and then public static is always used with the main method. Main method contains one argument called args, and args is defined of a string classes type. Now it contains three variables, int x, then we have other variables rand, y, z, and then finally max. So basically I will be introducing only these four variables, x, rand, y and z. Now what these methods are, what for I have declared these variables will be known to you in this slide. So I am calling random functions, I am calling abstract method, absolute method, I am calling the round method, and I am calling the power function. So all these are methods or functions defined into the math classes. So if you want to access any of these methods, you have to write the math classes directly. So it will give you some random value, it will be stored into this one, it will take the absolute value, it will be stored into x, it will give you the round of value stored into y, it will give you the power, and it will be stored into z. So the rand x, y, z is a variable to store the immediate result returned by these methods. And then finally what I have to do, I have to print those methods. So basically what I am doing now, system.out.println. Just remember once again, the system is defined into Java class, system is defined into java.lang. And now the another important thing which I will be taking up a little bit later on, what we call out. So the out is a class variable. Out is not a variable associated with any object. That is why I have not declared any object. Now system is again abstract classes type. So simply I have written system.out.println. So println is a method which is defined into print stream class, and system.out creates an instance of print stream class. So now system.out becomes an instance of the class where println method is defined. So here is this program. So simply I am printing the value of rand x, y, z, and max of course I didn't define. So these are 4 variables. Now finally what will be the output? Output will be, how I will run this program? I will simply run this program with Java, which is called the Java interpreter. My math will be the class name through which you have saved your file, and simply this will be some print value. So this is my first program. The purpose was to explain you some of the methods of a math class which is defined into java.lang. Let's see another program. Now program is, again we have a called character class. Now this class, again how I will go now, is the purpose is to, at least you should be able to write some trivial program. So I have defined one class called mychar. So we have a public class mychar. This class contains one method called main method. Now I have a 3 variables, all of char type, and assigned with a, z, a is capital, z is a small, and then there is a 5. So we have 3 variables of character data type which is assigned with different values a, z, and 5. Now basically what I am trying to do, now I have to, there is a method called, now I am printing. Now what I am printing now? Now is upper, just in this case character dot is upper, character dot is upper. Now the is uppercase is a method which returns true or false. If the value of C1 is uppercase character, then it might be returning true. If it is a lowercase character, right, then it returns a false. In similar case, if the uppercase, if the C2 contains the uppercase value, then it is returning true or false. Similarly, I can is a digit returns whether it is a digit character or not. In C language we have alphabetic characters, right? So we have A to Z, then we have a digit character from 0 to 9. So now see, if it is digit character, it returns true, otherwise it returns false, right? Two lowercase is another method which returns true or false if the character is a lowercase character or not. So the purpose again here is similar to what we discussed in the previous program, that I defined a character class which contains many methods which returns true or false and so on. Now finally I will be running my program like this, Java mychar, right, and then the value will be true, false, true, A, and something like this. This is the way you will be writing a small program using some of the methods defined into those classes, and getting some exposure to other classes and so on.